For 20 years, astronomers have been asking the same question over and over. Are there other planets out there like Earth? Not gas giants, not scorched balls of rock too close to their star. Actual rocky worlds, sitting in the exact right zone where water could stay liquid on the surface? We found plenty of candidates, dozens of them in fact, but every single one had the same problem. We had no idea if any of them had actually managed to hold onto an atmosphere. And without an atmosphere, even a perfectly placed rock is just that, a rock. Then, on July 16, 2026, that 20-year gap in the evidence finally closed. This is LHS 1140b, the first rocky planet in a habitable zone we've ever confirmed actually has air. Here's what made this so hard. Finding a rocky planet at the right distance from its star is one thing. We've gotten fairly good at that. But actually detecting an atmosphere on a small, rocky world is a completely different challenge. Gas giants are easy by comparison. Their atmospheres are enormous, thick, and easy to spot. A rocky planet's atmosphere, if it even has one, is a thin, fragile layer that can be scoured away by radiation from its star long before we ever get the chance to look at it. So for years, we knew where to look. We just didn't have the tool to confirm what, if anything, was actually there. LHS 1140b orbits a small red dwarf star in the constellation Cetus, about 48 light-years from Earth. It's what astronomers call a super-Earth, about 1.73 times Earth's radius and 5.6 times Earth's mass. Its host star is old and relatively calm, more than 3 billion years into its life. That matters because red dwarf stars, despite being small, spend a huge portion of their early lives blasting out intense ultraviolet radiation and violent flares. Most rocky planets around young red dwarfs get stripped bare before they ever get a chance to hold onto anything. LHS 1140b's star has settled down, and that gave this planet billions of years of relative calm, enough time potentially for an atmosphere to survive. You can't just point a telescope at a small rocky planet 48 light-years away and see gas floating around it. So, astronomers used a method built around something almost poetic, watching air leak away. As LHS 1140b passes in front of its star from our point of view, what's called a transit, starlight passes through any atmosphere the planet might have. If there's helium up there, some of it slowly escapes into space, forming a faint halo around the planet that very slightly dims specific wavelengths of that starlight. A team led by researchers at Harvard used the Magellan Clay telescope in Chile to watch for exactly that signature during multiple transits. And they found it. A clear signal of helium escaping from LHS 1140b's upper atmosphere, a phenomenon we already know happens on Earth and other planets in our own solar system. After ruling out other explanations for the signal, the team concluded this rocky planet is genuinely holding onto a real atmosphere. Not a hypothetical one, not a theoretical prediction, a directly detected one. Lead researcher Colin Cherubim put it simply, this is the first time anyone has found an atmosphere on a rocky planet in the habitable zone of another star. So, why did LHS 1140b make it when so many rocky worlds around red dwarfs don't? Part of the answer might be its size. At more than 5 times Earth's mass, LHS 1140b has stronger gravity than our own planet, strong enough to hold onto gases more stubbornly, even under the harsh radiation environment of a young red dwarf star. The other part is simply time. Its star calmed down billions of years ago, giving this planet a long, relatively gentle stretch of its life to keep what it had instead of losing it. Neither of those factors guarantees anything about life, but together they explain how this planet cleared a bar that most rocky worlds like it never do. It's worth being precise here because it's easy to overstate what this discovery proves. An atmosphere doesn't mean life. Helium alone isn't a biosignature. It doesn't indicate biology one way or another. What it means is something more foundational. This planet has cleared the most basic requirement for habitability that we can actually test for right now. As Cherubim put it, an atmosphere is essential for a planet to support life as we know it. Not sufficient. Essential. It's the floor, not the ceiling. For 20 years, we didn't even know if any rocky habitable zone planet could clear that floor. Now, we know at least one can. This discovery doesn't end the investigation. It opens the next chapter of it. Astronomers now want to use the James Webb Space Telescope to look more closely at LHS 1140b's atmosphere. Not just confirming helium is there, but trying to figure out what else might be mixed in with it. Water vapor, carbon dioxide, the kinds of molecules that would tell us whether this planet's atmosphere looks anything like Earth's or whether it's something stranger entirely. Every one of those follow-up observations builds on the fact that we now know for certain there's something there worth looking at closely. Step back far enough, and this fits into a longer story that's been unfolding for 2 decades. 20 years ago, scientists weren't even sure rocky planets around other stars were common. Then we found out they were everywhere. Then we started finding some sitting in the habitable zone, the right distance, the right temperature range. The missing piece was always the same. Does anything survive there? Does any of them actually hold an atmosphere long enough to matter? LHS 1140b is the answer to that question. Not a maybe, not a theoretical model. A real, measured, directly detected yes. 48 light-years away, there's a rocky planet sitting in the habitable zone of a calm, old star that has held onto its atmosphere for billions of years. We don't know yet what else is in that atmosphere. We don't know if there's water on the surface or anything living in it. But for the first time, we know the most basic ingredient is there. 20 years of looking, one planet that finally said yes. If you want to be here when the next answer comes in, subscribe. This is Space Report,